Good morning. Today we're going to be looking at how we can make a shape canvas that can handle drawing cool things like this, like where you can draw triangles, rectangles, ellipses, polygons, even clearing the image, adding some cool stuff, changing the amount of sizes and shapes, all that cool stuff, changing color, great wonderful things. So this is what we're going to be making today. Let's go ahead and take a look at the code. Switch over here to Eclipse. We have our ShapeCanvas.java. This is going to be our class we're working with. As you can see, I have a bunch of imports we're using. Specifically, I didn't collapse them out because I want to actually show you what we're working with. We're using basic stroke. Basic stroke tells us the line width we're going to be using. .color is how we can actually grab what color we're going to be working with. Dimension gives us sizes. Graphics and graphics 2D are how we are allowed to actually draw on the screen. Our polygon, rectangle, and shape and ellipse 2D all handle the information about the shapes that we're drawing within this. The buffered image is how we're going to save the image and work with it. File, IO, and exception to handle the IO with this. Same with image.io and the JFile chooser. The Java.util.ArrayList is to store information, and of course JPanel itself is their superclass that we need to have access to. And then of course we have our import for our controller, so we can use the model view controller relationship to pass information to the controller that we don't need to worry about. So we'll go ahead and handle that. In our data member section, we have 4 lists that we're working with: an array list of triangles, an array list of polygons, an array list of ellipses, and an array list of rectangles. Notice that the triangle list is also actually a polygon list. We're having a special thing for it because we're only putting triangles in that. We also have a reference to our controller, and then we have a private data member of type BufferedImage to handle the image itself. Again, because we're using a subclass right here, we have our first line of that's going to be called a super. We assign a reference to app so we can use it inside the actual app as a variable that we have access to across the entire class. We initialize our data members appropriately because, well, it's a really good idea to do so. And then we set our canvas image to be a new buffer image of 600 by 600, and then we're using the bufferedImage.type_int_argb because we want to be able to have our image support alpha channel, aka transparency. And so we're going to be able to save this to a PNG and have layered image information on top of that. We're going to use the set minimum size and set preferred size methods to say I want this to always look 600 by 600, and then set maximum size, call it preferred size, because we want this to always be that same size. Okay, really pretty easy. Now, although this is a subclass of JPanel, notice inside my constructor, I do not call my traditional JPanel methods of setup panel, setup layout, and setup listeners because there's nothing to listen for in this at this point. Right now, our shape canvas, all it does is draw stuff, and that's what we're going to be using it for. Let's go ahead and take a look at that. The addShape method we looked at earlier when we called it from our ART panel inside our listeners, where we call right here canvas.addShape. In our addShape method, it takes a shape parameter of current, and we're going to use the magic of polymorphism and Java's instance of keyword, where it allows the binding of the object so we can figure out what it is. And so if current is a polygon, then we go down here, I'm going to check the polygon, if the cast it, take current, cast it as a polygon, and because I've cast it, I can now call X points on it and find out the length and see if it's a triangle. Oh, its length is 3. The amount of 3 of X points on there's 3 different X points. Oh, it's a triangle. Then I'll add that to my triangle list. Otherwise, if it's 5 through 20, I'll add that to the polygon list. Same thing, I'm going to do an else if current is an instance of ellipse 2D, and I'll add that to my ellipse list. Otherwise, because I only have those 3 different types of shapes that I can use, polygon, ellipse, or rectangle, I put in my rectangle list. And then I call my updateImageMethod. So my updateImageMethod is where I'm going to change what's going to happen inside that. So let's go scroll down to that. Now in updateImage, I have right here, I have a graphics 2D object, which is current graphics, where I'm going to take the canvas image, the thing we draw on, I'm going to call getGraphics and cast that as a graphics 2D type. So I'm going to cast graphics 2D, and then I'm going to go through everything inside my ellipse list and call ellipse2d.current in a for each loop, and I'm going to randomly get a color, set the stroke to be a basic stroke of 2, so all my ellipses have a width of 2, and I'm going to fill it and then set the color to random color, a new color, and draw it. So I have the circle shape filled in, and then draw. I'm going to actually just draw an outline around it. So I have a nice little 2-color ellipse. For my polygons, however, in triangle, I'm only going to fill them. So I'm going to call set color and fill the current triangle. So all my triangles are going to fill themselves. For my polygon list, I'm going to do color and stroke and only draw them because I'm going to have possibly some really weird shapes. I'm going to have them set to only just draw. And then same thing with rectangle, I'm going to only have those get filled. And then because I want to deallocate any excess memory I've been using with that, I'm going to call the dispose method on my current graphics so I can deallocate memory so I don't have to have it going all the time. And then I'm going to use the repaint method. Repaint is how I'm allowed to actually call the redraw method inside a class. We don't want to call the method that does the repainting on our own. We use repaint to handle, so that way the swing library handles all the repaints that it needs to handle. And what that does is it actually calls this lovely method right here, paintComponent. As you can see, it's an app override method. This is something that's actually protected as part of the actual parent class where we get this from. So we're going to override it, and so it's going to do what the parent version says to do first, using super.paintComponent. But then I'm going to use that buffered image. I'm going to tell it to draw what's inside Canvas image, which again, I retrieve the graphics from up here inside updateImage. So every time I call updateImage, I get the image itself and get its graphics information, and I update it. And then every time I call repaint, it forces it to call paintComponent, which then says, oh, this is how I draw it. So that's how we go from there. So let's look at the helper methods we're using for this. We have our randomColor helper method, which I know, I like changing colors. I think it's kind of fun. We get random values from 0 to 255 by passing it a math.random times 256 for red, green, blue, and alpha. I pass those parameters to a new color object, which gives it a random red, green, blue, and alpha value. And as you can see right there, that's what it takes right there for RGB and A, and grabs that in there. And I use that to actually do that. The next thing we have is we have our clear method. Sometimes I want to wipe out everything I've done. If that's the case, I take my canvas and I reinitialize the data member by just passing the exact same thing when I initialize it the first time, wipes everything out of the actual canvas itself. But then I also wipe out all of my lists. And I use that by calling it .clear on each list, which takes all the values out of them, but keeps them initialized as a valid data member. And then of course, because I've wiped everything out, I want to redraw it, so I call updateImage. And since there's nothing in there, it's blank again. My changeBackground is where I use that random color, so I get the graphics for that thing. I'm using this time the createGraphics method, which automatically gives me a graphics 2D type. And I'm using then the current.setPaint to be some random color, where I just randomly get a color. And I then fill the rectangle starting at the top left corner, 0, 0, and I draw that for the width and the height of the exact image, which is, of course, as we know, 600 by 600. And then guess what? Yes, that's right. We call updateImage. So that way we can actually change our color right there randomly. And it'll update the image of just the actual image at that point, and then draws, of course, all the lists of all the different little shapes right on top of it. Ooh, pretty stuff. Finally, we have our save method. Our save method is how we can actually save that file and actually generate a regular image file out of this. So of course we have to do a try catch, because we can't guarantee we have access to what we're using. And so we have two different catches and we'll work with that. But first we use the JFile chooser. That's the GUI way of actually picking a file. And I'm going to call it save dialog because it's what it's doing. And it's a new JFile chooser. And then I say save dialog.show save dialog, and I pass it the reference to the frame itself. And so that's where I call app.getFrame, because that allows me to go inside and actually get the frame so I can have it centered on the window that we're actually working with. I then have a path that I'm saving it to, and I do save dialog, .get selected file, which turns the file itself, and then I'm getting the path of that. So I'm going to get the whole path that I'm using from my select that file wherever I specify it to, and then I'm going to tell image.io.write, passing it the canvas image, the actual image file that we've been drawing on right here with the graphics right there, the type PNG, and that's a new file, passing it that path that we just picked. So I get to choose where it's going to save. I do have two exceptions, like I said, to catch. An IO exception, like for some reason I can't save that file or something bad and it crashes and dies. Oh, I'll handle the IO exception with the handle errors method, or I'll do the handle exception of a null pointer exception if for some reason the user made the bad choice and canceled out the JFile chooser. I don't want my app to crash because they hit cancel. That would be sad. Okay, so let's go ahead and take a look and run this and see what happens. So again, we'll run this image. Welcome to the Art app right here. We have our blank screen because it's initialized at blank. Every triangle I click on this, it adds a new triangle, and we have those lovely triangles being drawn right there. Rectangles getting drawn. Look, nice little cute rectangles. Some of them are square, fantastic. Ellipses getting added right there. They have the nice little double color situation right there. Polygons getting added right there, also nice and cool. Change the number of edges on the polygon right there, so that's some nice weird shaped polygons. And because it's all squampified, they look really nice and crazy. And I can go ahead and change my colors, and that changes all the colors because it randomly redraws the colors each time. That's okay. I like this one, it's kind of nice. Let's try two more. Ooh, that one's nice and bright. And let's make these shapes a little bit bigger for the next set, so let's add some more shapes. Get a little bit more triangle on there, there we go. Get some more rectangles in, ooh, there we go. And add a couple more polygons, and a couple small ones. There we go. I have my nice little image. I want to save this. So I'm going to go click on Save Image. And I'm going to save this right here. It's in my Cody Hendricks. I'm just going to put this inside my Documents folder. I'll put it on my desktop. There we go. And first, art.png. Because again, that's what I'm saving it as. I'm going to go ahead and click Save. And I'm going to go to my Finder window. And in my Finder window, if I go to all my files, first art.png, and look at that. Look at that. It's a match. I'm able to actually save my image, write what I made. It's amazing. So I can actually create some art and have some cool things happen. So again, the way we work that, I'm going to go here back to Eclipse. I have my lovely class that extends JPanel. It has a couple lists of information we use, as well as a buffered image that I actually do all the drawing to. I initialize that appropriately using the type ARGB so I can handle the alpha channel, so I can have some layering to my image. set it a size. I use the polymorphism feature of Java and the instance of keyword because the interface shape can have lots of different subtypes, and instance of tells me where I'm going to put them into appropriate lists. I have a cleared that wipes it clean, a change background so I can get some pretty colors, and save because it's kind of nice to save my actual art right there. I really find it cool. And then of course I have my updateImage method that does the drawing of information, randomly going through each element in the list, sets the color, fills that, and puts it on the screen. And then, of course, calls repaint, because I can't ever call on my own the paint component. We don't want to call that. That's not ours to call. Yes, it's protected, but we don't call it. And then it just uses the graphics.drawImage and passes it the reference to the image that we've been working on the entire time. There we go, and thanks. Have a great day. Next time we'll take a look at some of the other structures that we'll be working with.